Hi students, welcome to physics classes. Today we will discuss about vectors. In the topic of vectors, we will discuss multiplication of vectors. Multiplication of vectors. Now already we know vectors can be added with different rules, not like scalars. Scalars can be added normally, but vectors can be added with different rules. Like this, multiplication of vectors also. Multiplication of vectors also has different rules, unlike scalars. So addition of vectors and multiplication of vectors is different. Vector addition, vector multiplication is different when compared with scalars. Now here when we add two vectors, for example, if you have a physical quantity and its vector a bar, and if you do addition with a vector b bar, we will get a resultant, that is a vector. When two vectors are added, we will get the resultant, again a vector. But when coming to the multiplication, when a vector is multiplied with other vector, its result may be either vector or scalar. When two vectors are multiplied, its result is a vector or scalar. That depends on the physical quantities we have taken. For example, if we take two physical quantities, position vector and force vector. Position vector and force vector. If you multiply these two, we will get torque. It's a vector quantity. Now if you take displacement vector and the force vector, if you multiply these two, we will get work. It's a scalar. Means based on the quantities we have taken, multiplication of two vectors may be either vector or scalars. Now if two vectors are multiplied, if we get the result is scalar, it is known as scalar product. It is scalar product or dot product. Now if you multiply two vectors, if you got the resultant is a vector, then it is vector product or cross product. Vector product or cross product. These are the two types in the multiplication of vectors. Now we will discuss one by one. First we will discuss about scalar product. Now we will discuss about scalar product. If two vectors are multiplied, if their product is a scalar, that product is known as scalar product or dot product. That product is known as scalar product or dot product. Now if two vectors a bar and b bar are non-zero vectors, a bar and b bar are non-zero vectors, their product means scalar product is product of their magnitudes. A bar magnitude is magnitude of a bar, b bar magnitude is magnitude of b bar, and the angle between these two vectors is theta. Now the dot product between a bar and b bar is magnitude of product of magnitude of a bar and magnitude of b bar and a cosine angle between them. Dot product a bar dot b bar equal to product of these three, magnitude of a bar, magnitude of b bar into cos theta. Dot product between two vectors is product of their magnitudes with cosine angle between them. Okay, now here a bar is a vector, b bar is a vector. If you do dot product between them, we already seen, we'll get scalar. Now here we'll see that a magnitude of a bar, magnitude means it's a scalar. B bar magnitude, only magnitude, it is also a scalar. Cos theta, it is also a scalar angle. So all are scalars. If you do the product, we will get scalar. Dot product is a scalar product. We will get the result is a scalar. Okay. Now we will see two vectors a bar and another vector b bar. One vector a bar, another vector is b bar, and the angle between them is theta. Now if you draw a perpendicular like this, now we already know this topic, resolution of two vectors. B bar is a vector resolved into two perpendicular components, then it becomes b cos theta. Now b bar vector b bar, its component in the direction of a bar, component of b bar in the direction of a bar is b cos theta. So if we do the product a bar dot b bar, here its magnitude is a and b bar in the direction of a bar is b cos theta, then we will get ab cos theta. Here a and b are magnitudes of vector a bar and b bar respectively. Theta is the angle between them. Here why it is b cos theta we know. When a b bar is resolved into two perpendicular components, this becomes b cos theta. When angle is theta here, this becomes b cos theta. If any component is here, vertical component, that becomes b sin theta. Okay, ab cos theta. Now in the previous case we have taken perpendicular like this. From here onwards perpendicular to the A. Now if you do the reverse, perpendicular drawn from A to B, it is making 90 degrees with the B bar vector. Now this is A bar, it is a vector. Now component of A bar in the direction of B bar, component of A bar in the direction of B bar is A cos theta, because it can be resolved into two components. A vector is resolved into two perpendicular components. Here angle theta, so it is A cos theta. Here it becomes A sin theta. So if you take here also A bar dot B bar equal to B in magnitude of B, A cos theta, will get AB cos theta. A is the magnitude of A bar, B is the magnitude of B. Now we will see some properties, like here A bar dot B bar equal to B bar dot A bar. Anyhow you can multiply in any direction. Now A bar dot B bar plus C bar. B bar C bar we are doing sum, after that we are doing dot product, dot equal to individual A bar dot B bar plus A bar dot C bar. Now if you take A bar is multiplied with A bar, same vector is multiplied with itself, equal to A square. A bar dot A bar equal to A square. How? Magnitude of A bar is A into magnitude of this A is A into cos, angle between them, angle between two same vectors. Same means this is a vector, another vector lies on the same vector. One vector, another vector lies on itself. So angle between them is 0 degrees. A into A square, cos 0 is 1, A square. Now we seen already A bar dot B bar equal to previous case we got A into B cos theta, A into component of B along A, component of B along A bar dot B bar we can write B component of A along B, both are same. Now we know unit vectors I, J, K are unit vectors along x-axis, y-axis and z-axis. Now if you take I dot I, J dot J, K dot K, already we seen two same vectors, if we do dot product square, just we'll get the square of its magnitude. Now we know I bar, J bar, I cap, J cap, K cap are unit vectors. Their magnitude is 1. So I dot I, J dot J, K dot K equal to 1. So if we do like this, I dot J, J dot K, I dot K, what will be happen? Now here I dot J, angle between I and J is 90 degrees. J and K is 90 degrees. K and I is 90 degrees. So cos 90 is 0. Cos 90 is 0. So I dot J, magnitude of I into magnitude of J cos 90 will get 0. So whenever we do dot product between two vectors, when they are perpendicular, then result is 0. Now scalar product by component method. Now if you have a vector A bar, it can be defined Ax I cap plus Ay j cap plus Az k cap. Another vector B bar equal to Bx I cap plus By j cap plus Bz k cap, I j k x y z. Now if we do dot product, a bar dot b bar equal to axi plus ayj plus azk into bxi plus byj plus bzk cap. It's very simple, like general multiplication, but we should follow some rules here. Now we can multiply generally if we have equation like this, x y z into x y z. Now with this we will multiply these three, and with this we should multiply these three, with this we should multiply these three, with these three, total 9 terms we will get. Okay, so instead of that we can do one simple thing. Already we seen I dot I cap dot I cap equal to 1, j cap dot j cap equal to 1, k cap dot k cap equal to 1, with the same product with the same equal to 1, remaining is 0. So whenever we multiply axi with the bxi, we'll get ax bx plus axi with the j 0, axi with the k 0. No need to do all. Now j ayj with the bxi 0, j with I dot product 0, j with j 1. So ay by plus ayj bzk 0, like that. Azk bx I, k dot I 0, k dot j 0, k dot k 1. So az bz, simple. A bar dot b bar equal to ax bx plus ay by plus az bz. We'll do one example problem here. If two vectors a bar equal to 2i plus 3j cap plus 4k and b bar equal to 5i plus 6j plus 7k, like this is there. Now what is the dot product? A bar dot b bar equal to, simply 2 5s 10, 3 6 18, 4 7s 28, 10 plus 18 28 plus 28 56 units. 56 is a magnitude, then it is a scalar. That is a scalar product. Okay, now we'll see some important points here. As we know, a bar dot b bar equal to ab cos theta. We can write cos theta equal to a bar dot b bar by ab, or we can write a bar dot b bar ax bx ay by az bz, ax bx plus ay by plus az bz by ab. Now they'll ask scalar component of a bar, scalar component of a bar in the direction of b bar. Scalar component of a bar in the direction of b bar is a cos theta. So a cos theta equal to a bar dot b bar by b. A coming this side, a cos theta equal to a bar dot b bar by b, when a component in the direction of b. Scalar component of a bar in the direction of b is expressed as a cos theta equal to a bar dot b bar by magnitude of b bar. Suppose they asked component of b bar in the direction of a bar, scalar component of b bar in the direction of a bar is b cos theta equal to a bar dot b bar by a, magnitude of a. Okay, this is about dot product. I hope it is very clear for everyone. Later on we'll do some problems based on this. Now please subscribe.